All right, so if I'm going to do this, I've got to do it quickly. This is called hydrazine. Thank you, Gabby. I appreciate your continued support. This is hydrazine. This is a very important reaction I spoke about, Red. Okay, so it says, number 60 says, hydrazine is used as rocket fuel. It reacts with oxygen to form nitrogen and water. How many liters of nitrogen at STP form when 1 kilogram of hydrazine reacts with 1.2 kilograms of oxygen? So I have 1 kilogram of hydrazine, 1.2 kilograms of oxygen. So let's write the mole ratios as they exist there. So that's going to be 28 plus 4 is 32, and this is 32. Clear? So what do you need? You have the same mass. The mass is the same, right? Yeah. So do you see what's going to be limiting and what's not going to be limiting? Yes or no? Yeah. So what's going to be limiting? Is there anything that's going to be limiting here?
The N2H4.
All right, let's see. This is 1.2 kilograms, okay? So 1 mole is 32 grams, 1 mole is 32 grams. Yeah. 2 moles would be 64. So there's a relationship, strangely enough, between the amount of hydrazine you use and the amount of oxygen you use. How many moles, what does it ask for? How many liters of nitrogen are formed? And that's going to be 1, 2, right? So that's going to be 1 mole. So how many moles? Isn't this limiting here?
Yes.
Okay, how many moles? So 1,000 grams of hydrazine. How many moles is that? Come on, guys. I got to go. I got to give presentations to the 7th graders. So you got to help me out here. Or I can't do it. What's 1,000 divided by 32?
Oh, 31.25.
31, say 30, can we just say 31 moles?
Yeah.
Right? So if I have 31 moles of this, how many moles of this do I have? 31 moles, right? So 31 moles at STP is how many liters? 31 moles times 22.4 liters. What is it? Right? Isn't it 22.4 liters?
It's 694.4.
694. Can we just say 694? Is that okay?
700.
Say that again.
You say 700. No, like that's more exact actually, because I use 31.25.
And you're also looking at the answer in the back.
No, I have my calculator. 700.
700?
I second the motion.
All right. 700 liters. 700 liters. Did something just go off? No? It's still running? Okay. 700 liters. And then it says, ladies and gentlemen, it says, and then we're done. It says how many grams of excess reagent remain after the reaction? How much?
200 grams.
200 grams, right? Is that what the answer says in the back, Gabby?
Yes.
I love I still like, I've been doing this my entire adult life and I'm still like a kid. I love checking the answers to make sure I do, and I'm always amazed I'm right. I am, I'm amazed. I was last in last in my class junior year in high school. Now the whole world knows that. Yeah. Cool, are we good? Shall we go over it? 32 to 32. So there's not only a mole ratio, there's a mass ratio of 1 to 1, right? So if I use 1 kilogram, I need 1 kilogram. If I use 1.2 kilograms, I need 1.2 kilograms. Limiting reagent is hydrazine. The number of moles of hydrazine is 31, 1 to 1. So 31 here, 31 here. 31 times 22.4 each, because I'm looking for, it says hydrazine is used in rocket fuel. It reacts with oxygen to form nitrogen and water. How many liters of nitrogen at STP form when 1 kilogram of hydrazine reacts with 1.2 kilograms of oxygen? So it's liters. 700 liters. 31 times 22.4 is 700. we're off. 200 grams, okay? Easy? Are we all right? Okay. Let me just put this up a little bit. Ella, would you get Mr. Patty, please? Tell him I've got to go. What is it?